Welcome to the second video for Unit 1. In Section 1.2, we're going to be learning about linear inequalities. The good news is this is a pretty simple, straightforward section, and it will reinforce those skills that we learned in Section 1.1 with solving linear equations. Now, before we get started, let's make sure we know the difference between an equation and an inequality. We're going to make one simple change to turn an equation into an inequality. So let's consider examples of both. An equation and an inequality. A simple linear equation in one variable might look something like this: 2x plus 3 equals 5. Whereas an inequality might look something like this. The difference between these two statements is that one has an equals, that's what makes it an equation. The other one has an inequality sign, that's what makes it an inequality. Now, in an inequality, we may see any one of our four inequality signs. This example has greater than or equal to, but you might also see less than or equal to, greater than, or less than. This is the type of expression that we're going to be studying in this section. Now, we're going to start at the end of the problem. Before we learn how to solve an inequality, we're going to look at several ways that we can express the solution to an inequality. The most important way that we do this is with something called interval notation. So section 1.2.1 is regarding interval notation. A set of numbers on the number line can be notated in three different ways. The first is called Setbuilder Notation. The second is a number line graph. And the third and most important to our studies is interval notation. So again, before we solve an inequality, we're going to learn how to express inequalities in these three ways. Interval notation, again, is the most important, and the more that we can master interval notation in this section, the better we'll be prepared for expressing the domain and range of a function in later sections in this class. So on the table below, you can see that we're going to compare the three types of notation: Setbuilder notation, number line graph, and interval notation. Now, just a couple of tips before we begin. When we have our inclusive inequalities, which are less than or equal to and greater than or equal to. Inclusive means they include the possibility of the equal to. So it's a greater than sign with half of an equal sign, a less than sign with half of an equal sign. When we have an inclusive inequality, we're going to use square brackets in interval notation. If we have a strict inequalities, which are the signs less than or greater than, no equal to part, then we're going to use parentheses in interval notation. This will be true again when we get to domain and range. So on the table below, we're going to start with what looks like the solution to an inequality. This is going to be the very end of our problem. After we learn how to solve an inequality, that's what the solution is going to look like. To put it in Setbuilder notation, we just dress it up a little bit. We add these curly braces. That indicates that we're dealing with a set. And right here, we identify the variable of the inequality, and the vertical bar is read as such that. So if I wanted to read this solution, I would say the set of all x such that x is greater than a. This is a fancy way of presenting the solution to an inequality, And we're not going to focus on that as much as we are interval notation. Now, assuming that a is some number, the solution to the inequality is any number greater than a. So let's suppose that a is somewhere over here on the number line. I want to shade all the numbers on the number line that are greater than a. So I'm going to shade the numbers to the right of a. So any point that I choose in that shaded region represents a number that's bigger than a. Now, as we said above, when we have a strict inequality, like greater than in this problem, we're going to use parentheses. So I'm going to indicate the endpoint of this interval using an open parenthesis. Now, every value in that shaded region, again, represents a solution to that inequality except a. So this graph shows that we're acknowledging all the numbers to the right of a, but not including a. To express this in interval notation, I'm just going to read that graph left to right. So I'm going to find the leftmost number in the graph. It's a, and we've already decided on a parenthesis. And then I'm going to find the rightmost number in the graph. In this case, there is no rightmost number, so we're going to call that infinity. And we always use parentheses with infinity. So the interval notation says that any number between but not including a on up to infinity would be a solution to the inequality x greater than a. Okay, let's practice that again. The next example, we would read the set of all x such that x is less than or equal to b. So we're looking at all the numbers on the number line that are less than or equal to b. b is just going to be some number on the number line, and I'm going to assume that it's about right here. We want to shade all the numbers on the number line that are less than or equal to b. Less than means we're on the left side of b. Now, since we're dealing with an inclusive inequality, or one that has the equal to as part of its sign, we're going to use a square bracket on our number line graph. So we'll draw a square bracket there at b. Now, to convert this to interval notation, we simply read the graph left to right. So I'm going to find the leftmost number in this shaded region, and notice it goes on forever and ever. There is no leftmost number, so we would say that it begins at negative infinity, and we always use parentheses with infinity. Then we identify the rightmost number in the graph, that's b, and we're going to use a bracket since we had an inclusive inequality. What that means is that b, the endpoint, is actually a solution to the inequality. b is less than or equal to b because it satisfies the equal to part. Now, if you'll notice on these two examples, we had our variable on the left side of the inequality, and notice the direction of the inequality indicated the direction that we shaded our graph. On this example, the inequality is pointing to the left, so we shaded to the left. I hope that those tips help you to master this interval notation. These two examples together are what we call simple inequalities, and we're going to learn how to solve these in the next section. The last one is an example of what we call a compound inequality. We would read this one, the last example, the set of all x such that a is less than x is less than or equal to b. So notice here we have x trapped between two values, a and b. So I'm going to put those two values on the number line, a and b. And because x is trapped between those two values, in this case, we're going to be shading in between those two values. So I'm looking at all the numbers between a and b. Now we have to choose the endpoints for our number line graph. Looking at the inequality sign associated with a, we recognize it's a strict inequality. It's less than. So we're going to use a parenthesis at the left endpoint of our graph. Looking at this inequality, because it's an inclusive inequality, it's less than or equal to, we're going to use a square bracket. Now, the way that I remember that, the horizontal bar here in the less than or equal to reminds me of the horizontal bar in the bracket over here. So the inclusive inequalities go with the square brackets. If it's missing that horizontal bar from the equal sign, we use a parenthesis. If that helps you, then I'm glad. Now, interval notation. We're just going to read the graph from left to right. So the leftmost value in our graph is A, and we've already decided it gets a parenthesis. The rightmost value in our graph is B, and it gets a bracket. That's what we call a half-open interval. So pop quiz, is A solution to this compound inequality? The answer there is no, because the parenthesis indicates we're not including A, we're just going up right next to A. Second question, is B a solution to the inequality? The answer is yes, because the brackets indicate that we are going to include B as a solution to that inequality. So these are the three ways that we can express the solution of an inequality. We really are going to focus on interval notation, so that's what we want to master. Again, that will help us to express the domain and range of a function later on. And next, we'll learn how to solve an inequality.